welcome to a quick little, what do you call, kind of a objective introduction to what we're going for. So here I've got, or also what to expect when using our web interface or using any of our products really. So here's an example of what you might create or what you might have somewhere. Um, I don't really want to go too much into detail on what it is quite yet, but essentially what we're trying to do is we want to create a texture map. And when we create these texture maps, we want also to be able to, as you see here, uh, define the colors and the way that the linear gradient will appear based on the values of your map. And when you're creating your map, you can create it many different ways. You can use our web interface to do so as well, but essentially what we're working with is we're working with an array of values. Now, before we jump into this, let me just go and show you kind of something a little more simple, and you can kind of see how it all will fit together, whether you want to do this on your own or whether you want to use some of our products or um, however way you want to go about looking at creating objects, or um, whether it's for manufacturing or doing it for animation. Uh, I can kind of show you how you can go about doing that. So let me see if I can find the page I was working with here. Okay, this might be one page. Um, no, I think I want to work with a different page. Let me see. Now, essentially, you also want to keep in mind that whatever you see on the screen is what you're going to be reading. Now, that seems like obvious, but I do want to say that whatever's on the screen is what you're reading. However, that's not necessarily what's being read. What's beneath the surface of your web page um, is always going to be more important than what you see on the page. Now, this is a good example of when we're working with our arrays on why animations are really important. But I don't want to use the word animation. I want to use the word timing. So when we're looking at our time schedule, as you can see here, I can refresh the page, but I'm going to hold off on that for a minute. When we loaded the full page here, uh, it wasn't necessarily, it didn't iterate itself all at once, but we don't quite know that unless we look at the code. And I don't really want to pull up the code right now. I guess I can, but essentially what you're looking at is you have these arrays, and the array is iterated all at once. However, it isn't displayed all at once. And so this is the two very important distinctions when we're looking at our code. Is the object, does it need to be separated uh, as the web loads, or can it be done all at once and then simply displayed according to the timing belt? And that really depends on the machine that you're working with. When we were working with manufacturing, the CNC program is going to be reading the what do you call, the program itself. So it's going to be reading what's beneath the surface. And when we refresh this page, it's going to be reading it in the order that um, it's being read. So, for example, if I have these arrays. And what's nice, before I jump into that, let me show you an example. So let's say that we move this box here. Let's say we move it down here. Okay. So I move the box down there. I can click save and it'll save where the location is, so that when I come back to this page, that's where it's going to be located. And what that means is it's going to update the X and Y variables, which it then retrieves upon loading. So that's really important because it detects changes that we may have conducted during our interaction with the interface. So there's different, depending on our web interface, and this is why the web is so important, and this is why these pages are so important, is because if you're working with manufacturing, whatever that you want done on your phone or on your computer or, wherever, I guess, because, well, whatever, but the point is, whatever work that you get done there, you want it to be able to communicate with the manufacturing devices that you may have working um, to create your product. So whether the manufacturing is a real object such as this um, uh, surface here. So this is a really important surface here because we're working with curves in terms of if you were to create any object really, you'd be looking at these curves here. But when you're actually creating the curves, it is uh, really, what do you call? When you're creating anything, actually, it really depends on not just how it looks, but is it even able to be creatable? So, doing this method, doing our approach, is going to make sure that no matter what device that you're using, no matter what instrument, whether it's a CNC or whether it's something different, that is going to be able to know exactly how to move, and it's going to not have any problems when you're doing your manufacturing. So it isn't just about how it looks, but it's also, is it even able to be accomplishable? Is the device even able to know how to work with that particular sequence of events to be able to create your product? Another important thing to keep in mind is if there's interruptions. If you have any interruptions during your instrument uh, process, then you want to make sure that it doesn't have to start over. Because if it has to start over, or if it has to, that's really something that's quite important when you're working with your manufacturing devices. Is if there's an interruption, uh, and one thing that was made clear to me was to make sure that you know the speed. If you set the speed of your machine and then you interrupt it, it's going to there's you have to know what that speed, what's going to happen to that speed, and also what's going to happen when you want to change speeds or if you want to change temperatures. You always want to look at what the previous temperature was. So if you have to reset a, sequence or something, you want to be able to retrieve the very last temperature that you were working with. So that's really important when we're working with location as well. So we want to know what the last location was, and when we're doing our interactions here on the web page, we want that to always be updating to set to set the last location that's going to be retrieved if this page were to be refreshed. So that was just something I just wanted to touch base on. Going back to this line thing, however, so now it depends on the instrument that you're working with. So I'm talking about the CNC. The CNC is going to be reading the assembly method that you choose to write. If you're not, if you don't want to use because we don't necessarily, if you're not an employee, we don't really want you to be on our website trying to, doing things that, I mean, you can do that, but it's obviously not going to communicate to the factory unless you pay for the product. So, um on the contrary, you can still design your work and you can still see what it was going to look like. And that's really quite nice. That's really quite fun. Um, and it's not too difficult to accomplish either, and I'll explain why in a moment. But I want to make it very clear that you can also do this yourself. You don't necessarily have to use someone else's product. You don't even necessarily have to, pay for the product. You can make it yourself. It just depends on, what are the instruments that you might need. Uh, can you create those instruments from scratch? And what else? Oh, using the physics basically. And uh, when you're talking about what you may need, the materials, a lot of these materials actually you can create them yourself. You don't actually source them in nature, so to speak. Uh, there's not that many products out there that require iron or that require, uh, you know, I guess it really comes down to not even that much copper either. So there's a couple of different things. Mostly we're working with plastics. We're working with carbon-based material, and uh, we're working with polymers. And when you're looking at polymers, and that's why I have this this modal here. I call it a modal, uh, as opposed to this equation here that I have set out for our texture map. Is That's something else I do want to explain real quick. Is when we're working with tables, we want our tables to, I'll go expand on that on another episode or on another one of our videos here. But essentially, uh, when you're creating these tables, you want them to already have definition within the web page or within the software or within, whatever it is that you're working with. You want it to already have definition, and I'll explain how we're going to go about doing that as well. For example, if you type in column 1, column 2, column 3, okay, that's great and everything. You can call it whatever you want, but we want it to, kind of make sense. But if you did call it something else, let's say you called it, I don't know, name, first name, last name, phone number, that's not necessarily something that's going to make sense in our modal. So if it does detect these words, these syntaxes, we want it to be able to know exactly what to do with that and where to put those items. Um, so that's something that we're going to touch on as well. Um, but real quick, let me talk about this modal for a minute. So what's nice about the modal is it doesn't really tell us anything, just by other than its appearance, really. But here I've only really explained the point. So as you can see here, this is defined by 4 coordinate points. If you look at I'll open up the thing here again. Oh no, sorry, 3. Yeah, sorry, 3 points. Yeah. So essentially, that's just our X, Y, and Z location. But really, it doesn't really need to tell us much else, just off first glance, and when we're trying to design our polymers. But it could later on as we add to our columns and as we recognize each syntax and how to sort that information, that when we include these modals, no matter what the modal is, we want the table that it is using, to be able to and I call it a table, but it's really not even a table. But anyway, we want the modal that we're using to automatically know what it is. And so when we're looking at polymers, something that's really important about a polymer is its characterization or its nature in terms of the environmental, uh, in terms of its environment, really. Because when you're working with polymers, the polymer is going to behave differently when you're looking at it uh, in a temperature. So when you're looking at a polymer in a particular temperature, it's going to behave differently. It's also going to behave differently depending on the time. So if you create a polymer, you're looking at two very important things. You're looking at the time of a temperature. So if you set a temperature, and this is why we're working with CNC, but we're also going to be working with rollers as well, temperature rollers. And what's nice about a temperature roller is that it sets a feed, so it's going to be generating these polymers across a surface. And also, when we're looking at our Arduino displays, we're also going to be creating some displays as well. When we're looking at our Arduino displays, it's actually created with crystals. So and that's very much like the polymers in terms of its uh, interrelation as chemistry goes, or in terms of the inorganic nature of elements. Uh, but let me see if I can pull up that page real quick, because I had it open. Okay, yeah, liquid crystal displays. And this is really important because when we're looking at the liquid crystal libraries, this is something that we want you to be able to use in your development as well. So you can use, and as you can see here, the Hitachi HD44780 driver. Each instrument is going to have its driver, and that's essentially, what we're creating. So when you install the driver, it automatically knows how to communicate with whatever it is that you're working on. So it's going to include everything. And it's really the driver that you need. Um, but a lot of times the drivers already exist. So as you can see here, uh, this is pre-made. So we didn't create this. This display was not created by us. So that's why it has its own driver, and as you can see, it has a name, Hitachi HD44780 driver. Now, when we are creating our own polymers or we are creating our own liquid crystals, we are going to automatically have the library that you're going to need. So these libraries are usually based on H headers, and these H headers are universal. They're going to be able to incorporate Fortran, feed, as well as and for and the Fortran mathematics, and it's also going to be able to communicate with R. It's going to be able to use your C or your Objective C if you're working with Apple products. So no matter what the product is, we really want you to be able to use our library, and that's going to make it so that you can reference our syntax, and it'll automatically, help speed things up if you want. So, something that I wanted to mention here. Okay, so essentially here we have these data pins, and we also have power supply pins, and there's a couple others. This has LED backlight, but so essentially we're looking at where to place the pins, and then we're also looking at what is the data for those pins. So if you look at this, for example, this is our modal. It looks like a molecule because we separated it. Well, that's what we created, essentially. But when we're looking at the what do you call the pins, it's not usually going to be looking like that. It's usually going to look like it's more like on a flat surface. So, and also with our pins, we may have them round there, but we may on our appearance change the radius of our spheres so that they look a little bit smaller. But essentially, you'll automatically be able to recognize what it is that you're looking at just based on what it looks like. So that's quite nice about, our time on Earth. So looking back on the liquid crystal display, so there's a couple information. If we do write in our column the ohms, for example, although the quantity within our data is scalar, we don't necessarily, when we're creating our arrays, we don't want to necessarily write 220 ohms because ohm is not something that we can use in terms of our uh, ability to calculate. So, however, it is. If you did type in 2020 ohm, it should technically you can know what that is, and then you can convert it if you want. This depends on the design, and there's different approaches, but it's pretty much the same thing. And I'll show you what that looks like in a minute. But essentially, you want your column, whether you call it ohm or whether you call it whatever, to automatically know what to do with that information. So this is important. Also, 10K ohm potentiometer. 10K is not even a real thing, but it stands for 10,000 ohm potentiometer. I'm pretty sure 10,000 kilo ohm potentiometer. Probably. I'll have to figure out if that's correct or not, but for right now, it doesn't really matter. Essentially, we want our syntax to automatically know what that means and to exchange it for the integer as needed. So that's something that's really important because when we're looking at this texture map, if I were to select an integer, let's say, or maybe I should look at this one. If this is the same thing, and I'll explain what it is or what differentiates it in a minute. But essentially, this is the exact same equation here. If I select a point on my graph here, it's going to tell me the information associated with where that data point is. So it's going to tell me the x value is 1.8825, and I'll explain also why it has to be looking something like that. And then our y value is y equals 1.0870. Our r is 1.8825, and our omega is 1.0870. So when you're looking at significant figures are very, very important when you're doing any work. And all of your information, whether you're working with super large numbers or super small numbers, you want always that your final display to tell you the four significant figures after the decimal place. So if this number was 1,000, I still want to see four significant figures after the decimal place. And the reason for that is because when we start working with R, it's going to be very important that we include what the error margins are. And also, error margins are very important when we're working with CNC because our CNC location can't, if it's moving from one point to the next point, it has to be definite that that's the point that it's going to. Otherwise, it's going to screw up the machine. You're probably going to break the whole machine, and you're probably going to have to call the manufacturer. So essentially, that's going to be us when we start creating our own products. Is you're going to have to call us and tell us why you broke your machine. But really, why did you plug in your own driver? Don't do that. Use our driver. So that's also, you don't necessarily use someone else's product. Or you don't use your own product. You use what's available. But at the same time, it really depends on what's going on and if you know what you're doing. So, when you're looking at energy, anytime that you're working with energy, whether you're working with solar, whether you're working with whatever, you can't just go out there and do your own thing. Physics is actually a highly regulated thing. You can't just go out there and advertise your own energy machine or advertise your own solar product. You can't just go out there and advertise your own software either. It's the exact same thing. So when you're looking at the distribution of your packages, you can't just go out there and advertise your own package, because let me show you why. Let's say that the package includes something that you may not want. Your consumer doesn't necessarily know that. They're using your package thinking that you know what you're doing, or maybe that you do know that what you're doing, and then you're taking advantage of your customers, or you don't even know, or that you cause a whole, what do you call, collapse in the whole model. For example, let's say that you plug in your house. You decide you're gonna have your own house with its own electricity, and you plug in your electricity to the mainframe, and then all of a sudden, because you don't know what you're doing, or maybe you do know what you're doing, doesn't matter, the electric company now has a problem because you created a something that is going to be somewhat harmful to the whole energy system. So that's really something really important when it comes to physics, is you can't just go out there and do your own physics. You have to work for a company. You have to be trained by the university. You can't just, when you're looking at other countries and you start working with engineers from other countries, you can't just go out there and hire an engineer from another country, because you don't know anything about them. You don't know anything about their education. You don't know, just because they have put a school on there, you don't even know if that school, what their intentions are. So you can't just go out there and start hiring people that look like they know what they're doing, because they may know what they're doing, but that may be exactly what is the downfall of your company. So, whether you're a country or whether you're a company or whether you're a consumer, it's the exact same thing. Don't be stupid. All right, so now that I'm off that, because I just get so pissed at these stupid pieces of shit, and maybe I have to edit that out later, but it's everybody, it's everybody that wants to go around interrupting me, that wants to go around and tell me that I can't go to school. They want to go around and give my job to Russians. They want to go around and call the doctors woke. I don't even want to be alive. Anyway, I might have to edit that out later. Back to the point at hand. So it really depends on the instrument that you're working with. So I explained about the CNC, and that the CNC is going to be reading the assembly method. And when we look at this display here, we don't actually know what the assembly method is. We don't know anything about the page. We don't know what's going on this display. Only the CNC would know. And let me explain something that's really important. Even if I click to show me the source, view the page source, I'm working within this program. And this program may not be knowing what I put into this actual source. That's something that's really important. And even if it does know what it is, it may not even want to show you anyway. So let me explain something really important. It really depends on what is going on, what is the mechanics of the whole construct, and what is the sequence of events that's happening for it to know what that syntax is. For example, if I go in here and I type in a hash symbol, it may register that as a comment. Now, on some devices, it may show you what that comment is, but on other devices, it may not. So it really is the same thing. And I'm working a lot with PHP. PHP is a great example of what I'm talking about. PHP is going to render your data because it's shell-based, so it's going to be rendering your shell activity on the display. However, when you're looking at the actual source, it's not going to tell you what's included in that PHP. In fact, everything in the PHP is hidden from the source, or it's hidden from, the application. However, it's operating out of the source. Now, when you're looking at the instrument, I said that the CNC is reading the assembly, and so it's really important what our assembly method actually is. And that's something that when we're looking at our texture map, that's really what we're working with, is we're making sure that we're providing the arrays in such a way that our assembly method will function according to what we want, according to what we expect it out of our performance. And then that's also going to be what allows for not just our animations, but our reverse video cohesiveness as we go from one point to another point, or as we rotate something, we want it to be able to what do you call it, to iterate the next array, I suppose. Now in this one, it's quite nice because you can rotate this. Over here, you can't rotate it yet. I can go over here and I can go like this, and I can move it across the two-dimensional axis, or what appears to be two-dimensional axis. Over here, if I refresh the page, it's going to, this timing belt is automatically set, so it's going to change the view automatically preset. So, I could shorten that length and I could make it look like something is rotating in the three-dimensional axis, but there's no interaction there. So you may want to think about how we interact with our interface in future development. But essentially, it depends on our JavaScript functionality. And so in JavaScript, you can, just like on here, I'm moving it, but I'm only moving it after I activated it. And also, you can't see, or maybe you can, I don't know, but I'm not actually clicking on this. I'm not holding this down. It's following me. If I move on this screen, this is following me. Okay? So that's something that we want to make sure that we show, is that when we move across the screen, we want it to be able to know which array to display depending on our location. So that's something that is a little interesting, because if we move over a location, then that location has a coordinate. So if we move to another location, then over that location it's going to show a different, or it's going to do something different. So, but it depends on our assembly sequence. So just like the CNC, if I were to move my mouse to the left, it's going from the origin, but not even. It's going from the last position to the left by so many points. If I go to the right, it's going from the last position to the right by so many points, as specified by your cursor. So when you're looking at the function to get the cursor position, that's something that's quite important when we are designing our assembly. It has to retrieve the cursor position, not just upon clicking this, because I click this, boom, it gets cursor position, and then it moves it, as you can see here in our corner, and it updates what the position is. Now that's great and everything, but we also want that to then feed into pretty much the next one. So if I were to go and I were to move this down by so many, 388 by 94, we want those two numbers to be the coordinate for the next array. So that's really quite important when we're looking at this here, for example, is I'm clicking on this point, 257, 0.79, just like on our other screen. If I were to move over to this point, it would be 279084. Now, that only happened when I clicked on it. Now, the very important thing is that when you're looking at CNC, the click is in the actual event of its position there. So when the CNC moves to the next position, you can count that as a click. So on this one, there's no click. We're just moving it around. Now, that's great and everything, but that's not what a CNC does. So that's quite important. It makes it a lot easier uh, when we're working with our assembly sequence, which we'll show you later. Part of it's already done, but I'll show you later. That's going to be a lot different than something like this. Something like this is automatically on the animation, and when we go over here, we are rotating it. Now, that functionality is just like our click, and it's just like our hover, but without actually having to move the mouse. So as you can see here, I held it down without moving the cursor. I mean, the cursor is moving, but I'm just holding it down and then rotating it. Now I'm holding it there, and the mouse is moving, and I'm rotating it, but then here, it has to know where to retrieve that data. So that's why when we're looking at how we design our arrays, it's really quite important, because let me show you what it should look like. So that's one integer, 19. And I think I have the other one here. When you look over here at our PHP, it's opening the bundle, it's opening the line, and it's reading the line. Oh wait, that's not what I'm looking for. Sorry. It's opening the position somewhere. Here it is. It opens the position, tells us what to do with it, and then closes the position. So when we're looking at our assembly could be, like I said in the beginning, a sequence of when does it open, when does it, based on the timing of, when you load the assembly. And that's probably going to be our best approach. But when we do it like that, then when we go over here at this part, where it retrieves the position, it gets the cursor position at startup, but then it could also get the cursor position when when we click on the event. Or I guess not when we click on the event, but how do I explain? When within itself, basically. So over here it updates the value, but then underneath we can also have it so that it will initiate the read itself within this. So when you're looking at this part, it reads it at the beginning, but then what we're going to want to do here is we're going to want it to be able to read as well, because we opened it, we closed it, and then so it's closed. So then in here we have to open it and close it as well. And that shouldn't be too difficult. So we'll have to add that in a bit. So that's something to consider. And what else? I want to just show you real quick. That's going to be important when you're working on your own textures. Is the linear gradient. So basically here we have a linear gradient that you could apply here when you iterate, for example, a line. So here I iterated a line, and I just specified here the fill, and here it's going to read the line for every character. Now it's going to read every character, but you could also have it read every line. You don't have to necessarily do it by every character. You could do it by line. And it really depends on what what the nature of the array is. So we can talk about that later, but essentially it makes it a lot easier when we're doing our work here, is that when you read a position here, you can specify the linear gradient, but what we'll want to do as well is figure out if that's even possible in a Savage. So we'll have to explore those kind of questions, but essentially linear gradient is something that we want to really keep in mind when we're working with our object. Is our object going to be a position? Is the object going to have an object definition? And right now we're working with Savage, but it doesn't have to be Savage. It could be something else. So essentially, when we're working with our arrays, if you look at, oh, well, it doesn't really matter. Earlier I showed you it was one integer, 19. That's basically what we want to see in our texture map, is whether we're working with Savage or whether we're working with the location of X and Y or whatever it may be, we really just want to see one integer. And it actually makes it pretty easy, because when we go over here, we have column 1, column 2, column 3. And when we do our editing, we're only editing one thing at a time, and that makes sense because we can't really edit two numbers at once. You can't type in two numbers at once. I mean, you can replace one number, you can replace a bunch of numbers at once with the number that you type in. Now that's something that we're going to want our arrays to be able to, or that's something that we want our data frames to be able to do with our arrays. But essentially, it makes it a lot easier. So when we're working at our organization here, we want to make sure that we know the time for each integer. So right now, if you take a look at what we got here, I just have it on one directory: X, X1, X2, X3, so on and so forth. Y, Y1, all the way, so on and so forth. Now, each of these is going to represent a time, and it's also going to represent, the time of that event. So it makes it a lot easier to kind of do it like that, because when we're looking at this, although the event is all at once as our whole object, the actual manufacturing of this object isn't all at once. It can't be all at once. So it depends on what the instrument, how it works. Generally speaking, it begins on one point, and then it begins on one length, and then it moves, or it feeds, or basically it moves to generate the full length. So depending on the duration, or depending on the length of what your product is, or what you're going for, that's going to determine the duration of your instrument. So what else is important? Linear gradient is also really quite important, because you see here I have this green piece. Green is not necessarily what we want, but it may be what you start with. And essentially, we want it to be able to get to what we want to see, which is something more like this. So this is quite nice. We want it to look something quite like this. But when we go to these different versions, we want the version to automatically update the value and vice versa. If you are changing the appearance, you're actually changing those real values. So that's something that we want our system to keep track of, is when you're looking at the next excuse me, the next variable here, a variable set, it's gonna go. Let me think. Omega, for example. If we select that particular linear gradient, it may not be omega. It may have a different one. It may just say like color or something. But it's gonna be in the order. It's gonna be the next iteration of that. And the reason why that's important is if you want to undo what you just did, you want to go back to the other color, you want to be able to do that. So that's going to, it's not a matter of changing the integer, but you want it manually. You just want to be able to go, Control Z or something to go to the last one. And that's not too hard either. But you also wanted to, if you wanted to go forward, you want to, be able to go forward as well to redo. Um, if you want to go to to the latest one that you're working with. So that's why no matter what it is that you're working with, whether you're working with your modal tables, or whether you're working with your art packages, or whether you're working with your arrays for Panda, or whether you're working with your what do you call your web interfaces, you essentially want everything to have those, you know, that versioning where it goes to the next one, to the next one, to the next one. So, also, what else? Oh, you want it to be separated individually. You want to make sure that each part is generated individually. And as you can see here, I have this is the page that is the main page that you'd be viewing on the web interface, but it opens another one to read it, does something with it, and then closes it. And it does so by reading each character, and it also does it on a loop as well. Or not a loop, but does it in a while, and does it on a while um, cycle or function. And it doesn't take too long, but you could change that while to, or you could have it be for each um, row, or for each integer if you wanted to look at the length, or if you wanted to find the length, things like that. So we'll explain that a little bit more later, because this video is kind of getting a little bit long. But basically, let me think. What was I thinking about? Uh, let me think. That might be it. That might be everything that I was thinking about. Um, oh. Also, it makes it a lot easier. Let me see. What is it? Oh, was it this one? Yeah. Okay. So, for example, this is Graph Bundle. This is one of the pieces that it may be wanting to read. So, if you go over here and you created a new file, and it's referenced in your main page, you may be going over here and writing in your assembly that you wanted to read a particular file, and you have that file on there, or to read a particular, let's say like a date, for example. Like if you have all the dates of the future already written out on a page, and if if you had if you detected something created at that date, then it would automatically populate. If it doesn't, if it says no files found for that read, um, you know, then you know that it doesn't exist. So, or that nothing was generated at that date. So essentially, you can do a condition there also where you say if the output says that, then skip the view. But if it does say, then you don't skip that view. So essentially you can do a lot with this. So whether you're working on with our software or website or factory or whatever, or whether you're doing your own, these are some questions you want to think about when you're talking about your design. Is when you're typing something, you generally want to just be able to open up a fresh sheet, and that for that to be what's going to be iterated in here. And also, the reason why we want to do that is it helps so that we don't have to worry too much about whether it's going to work or not. So, for example, on this one, this is going to work quite nicely. However, I've referenced something that may not work. So here I've written this out, and it may not work, but if over here I had a script or I had something that included what to do with it. So, for example, it may be something different. It may be the syntax I was talking about earlier, where I said if it includes the omega or if it includes the what was it called, the ohms or whatever, that it should automatically know what to do with that. And that's essentially what we want to be able to to keep in mind, is we want it to be able to know automatically if you have something that you're typing out, your array, for example. Let's say you're typing out your data. You're saying, oh, on my machine needs this much ohms and it needs these many. There's this much draw. There's uh, this is how many words that I've written, or whatever. We want it to be able to parse that information, but not just to be able to parse it and sort it in our data frame, but we want it to be able to exchange and convert those values into the required. So if you type in 4 inches, then it goes and converts it into the appropriate centimeters, so on and so forth. So things like that. Anyway, what else? Let me think. That may be everything. Oh, if you went in here and you typed in, you've created a fresh sheet, for example, like you don't even have to create the add button, or maybe you do. Maybe you want to add the material, or maybe you just want to read. Maybe you have a PDF, for example, and your PDF says carbon. We automatically want to be able to know, or you want to be automatically know that when you're writing carbon, it's going to not just be a word, it's going to actually create carbon, or it's going to actually call the carbon. So that's really important. That's what our system can accomplish also, is you type in carbon, it says, well, if there's carbon in your syntax, then our syntax automatically knows what to do with that. And you didn't even specify the length, but depending on where you did your interaction, we'll know exactly what the nature of what to do with that carbon is based on the parameters of that particular location. So that's why the array system for your texture mapping is really, really important, and how you go about doing that, and not just your tables, but how you go about creating your tables, how you go about creating your arrays, and how you go about creating your MySQL. This is all very, very important information, because although when you perform your data analyses using R or whatever, or if you're looking at what the statistics are, the statistics may be the same statistics. You may have the same. You may come up with the. If you go over to JavaScript, for It's in here somewhere. Oh, here it is. Alright, cool. That makes it a lot easier. Anyway, if you wanted to go over here and you just wanted to type in, C equals Y plus B, and you didn't really want to worry about too much, it gives you an answer 4. If you wanted to type in 1 plus 2, I don't know if it's going to tell me anything. Well, yeah, it does. 3. So that's great and everything. But if in my system, as you saw, I typed in C, I typed in Y, I typed in B, it gave me 4. I typed in 1 plus 2, it gave me 3. There's a huge difference if I typed in 1 plus 3, 4. Although the answer may be the same, although you may be correct and you use one of your R statistics to be able to create the same answer, it doesn't necessarily mean that it's going to be the, what do you call it doesn't actually do anything. It doesn't actually mean anything except for what it actually is. So for example, if I were to create this texture array in a different program, or if I were to create it using manually, now as you can see here, I did not create it manually. I used the equation. So that's really important, because if you draw something, it doesn't necessarily mean that you know what the equation is, but you can calculate it if you wanted, using, using the way that you go about it. And so that's really what we want to be able to accomplish also, is if you're looking at this particular texture gradient, if I were to see this texture gradient somewhere else, or if I were to want to import that texture gradient, I would want to automatically know what the mathematical equation for that is. And I would also want it to be able to show me what the specific values are for each data point. So we're going to go about in another video on how we can go about doing that as well. But essentially it comes down to what is the nature of the texture gradient, and what is generating that particular display. So if you're looking at a PDF, for example, a PDF, you can go from a PDF to a PostScript, or you can go from a PDF to an image, or you can go from a PDF to a text. But depending on what the nature of that particular the particular information that's within the PostScript, or that's within the PDF, or that's within the image, it would give us something a little bit different. So it really, trying to go about doing it like that doesn't really make any sense. But that's essentially, kind of the same thing. Is you're looking at something that's two-dimensional, but that you're looking at that two-dimensional object and you're turning it into a three-dimension. And if you are looking at a PDF, for example, you can look at the images. Let's say you're looking at a video, for example. You can look at the images and you can extract the text out of the images, but it doesn't really make it feasible to try to extract the code from it. So or if the code is not text based. So something that's really quite more simpler as an approach to that is, let's say that you have a video, and I'll make a video on this also, but you can turn your video into a PDF, and I'll show you how to do that with one step. And you can even use our software if you wanted to download it. I'll give you a link later to be able to do that if you're using a Mac. So essentially, or if you want to do so with your website, if you are on our website, if you want to upload that, we can give you the PDF version if you want. Or it doesn't really matter. But essentially, let's say that you take a video of your textbook, and you're reading your textbook and you're scrolling through your pages, and you want to extract the text using that video. We can accomplish that for you quite easily. But once again, when you're looking at a table, or if you're looking at a graph, let me say you're looking at a graph and you're looking at it in PDF, it's not moving, so that really helps. But you're looking at a picture, but then it should also say within that particular area carbon, or it should tell you what the material. It should tell you the title, and it should tell you the caption. And that's all you really need. Is you didn't even need the graph at all, but what you saw was the title and the caption. So when you're registering your modals here, I wrote column 1, column 2, column 3, but it's essentially where is it located, and then that's going to be the syntax that is going to actually give us the rendering of that graph in this three-dimensional form, which is quite nice. So it isn't just a matter of writing out the equation, but we wanted to be able to recognize that equation without even looking at the graph, and then tell us what that graph is based on our assembly method as we do our arrays. So the design for that is super simple. You can do it yourself. I'll show you how to do that. And then you can use this in creating your own animation studio or your own game engine or your own modeling software or modeling website. You can use this. It's really easy, and you don't even have to use our library if you don't want to. So I'll show you how to do that. But this is generally kind of a little overview on things to keep in mind. All right.